Okay, the last section in chapter 4 is 4.7, triangles and coordinate proof, as we listened to a little bit of, I think it's Neil Diamond. Chestnuts roasting on the fire or something, I don't know. A little mood music. Okay, triangles and coordinate proof. Now this is a little strange stuff. It's a little like a puzzle. What we're doing is we're putting triangles on a coordinate grid on an XY axis, and then we're trying to figure out what the coordinates of each one of those points would be, where we would put them. Now, where in the world would this be useful? When I was in college, one of my professors in one of my programming classes that I did use for computer programming actually worked with the government, with NASA, looking at data that was transmitted back from satellites that were in space. And when he could, he would talk to us and share with us some of that information, actually share with us some of the printouts of that information. And it just looked like gibberish until he began to interpret it and show us what was going on. And a lot of the information was simply the relative distances of different objects in space. And in order to find out where that object was, it would have to be graphed on a grid. Now, obviously, it was a three-dimensional grid, but the same references. And so what you would have is you would have a frame of reference or a data point that would serve as the origin for that particular set of data. And then there would be a relative distance in a certain direction, and you would plot that point or that characteristic of the object, and you could therefore find out where those objects were in space and what the distance was, and begin to find out what they were and begin to draw pictures of them. So, does this have a purpose? Oh yes, it has a purpose. And if you pursue higher level math, used in all kinds of areas and ways, think about atomic science, nuclear science. You're talking about plotting relative distances of particles, atomic particles, and those kinds of things. Where are they? Where are they located at any point in time on a coordinate grid, a three-dimensional coordinate grid? So, the concept is we're going to have a characteristic here and see what this is. Our first one is we have a triangle. We've placed it on a coordinate grid. Oh, let's go over here and talk about the steps for coordinate proof. Steps we need to use is number one, use the origin as a vertex or center of the figure. Wow, why do you want to use the origin? What's the coordinates of the origin? 0, 0. If I put a vertex or a corner of my figure on the origin, boom, that's an easy one. Wow, got that made. Number two, place at least one side of a polygon on an axis. Why? Why do I want to place one side of the polygon on an axis? Well, if I've got two coordinates, an x and a y, if I place one of the sides on an axis, well, one of those coordinates for that endpoint is going to be 0. Number three, keep the figure in the first quadrant if possible. If you keep it in the first quadrant, I'm only dealing with what kind of numbers? What are the signs of the numbers in the first quadrant? They're all positive. Makes it a little easier. Number four, use coordinates that make computations as simple as possible. Well, yeah, duh, I don't want to have to do hard math if I don't have to. So try to make coordinates and use it, set it up. Now that takes a little bit of practice and used to. So here we've got this one. We come along and we say that FG is equal to what? A. So this distance right here is A. And we say that FH is B. Okay? So what we want to do is we want to find out what is the coordinate. Oh yeah, we're not using numbers as such. We're using algebraic expressions and variables A and B to represent the distances. But what we want to do is we want to come up with what is the coordinate of F. What's the X and Y in F? Well, duh, it's at the where? Origin, I got that one. Y'all get the others. G. Where is it? How far away from F is it on the x-axis? Well, if F is at 0, and the distance between F and G is A, and I'm going along the x-axis, and the distance from F to G is A. Oh wow, how far up did I go along that y-axis? I didn't go anywhere, so the coordinate is A0. Well, let's go find H. Where in the world is H? Well, H is B distance away from F, but it's on the y-axis. So, how far off from F, how far away from F is it on the x-axis? Well, it isn't. It's 0. How far away is it on the y-axis? It's B. Okay, so there you would have, there are the coordinates for those 3 points. F, we put at the origin. Boom, that's 0, 0. G is A away from F on the x-axis, so it's A, 0. H is B away from F on the y-axis. Okay, so let's set it up like that. Now, let's go over here and look at this one. Set up another one that's a little different. Notice that it's a right triangle. Oh, it's an isosceles right triangle. And we're saying that this right here is equal to C. So LN is C. Well, what do we know? What do these little signs mean? Well, this is the same distance as that, so this is also C. So the distance from L to M along X is C. The distance from M to N parallel to the y-axis is also C. So let's find out where these are. L. What's the coordinates of L? What's at the origin? What's the coordinates of the origin? 0, 0. Well, let's go get M. M is how far away from L along the x-axis? It's C away from L, so the distance is going to be C. How far away along the y-axis is M from L? Well, it's not. It's on the same axis. It's on X. So that's going to be 0. Now let's look at N. How far away from L is N on the x-axis? Well, MN is parallel to the y-axis. How do we know? Because it's perpendicular to the x-axis. Anything perpendicular to the x-axis has to be parallel to the y-axis. Why? Because x is perpendicular to the y-axis also. Okay? So 2 lines perpendicular to the same line are parallel with each other. Okay? So MN is parallel to y. So therefore, N is how far away from L on the x-axis? It's C. Well, how far away from M is it along the y-axis? It's also C. Okay? So L is at 0, 0. M is at C, 0. And N is at C, C. Okay? That's how coordinate proofs work. We're going to do some samples of these that I think you have in your study guide. We're going to do some of those and work through them real quick. And so we'll do some samples, and we'll be through this chapter.